DOE is the largest federal sponsor of basic research in the physical sciences. This committee's jurisdiction includes all of DOE's civilian research, including almost $13 billion with a B, in research, development, demonstration, and commercial application programs, as well as the department's 17 national labs, which amounts to about 1/3 of DOE's total budget. As ranking member of the Energy Subcommittee, I take great pride in this responsibility, and I believe that one of the most important pieces, if not the most important piece, of our portfolio is the DOE Office of Science. That's why I'm a little surprised, quite frankly, that this Congress, this is the first hearing we've had held on this agency, especially since the Office of Science is a $7 billion with a B dollar program that represents actually more than half of this subcommittee's jurisdiction. Instead, last year we had many hearings on advanced renewable energy technologies, from solar and wind to sustainable transportation to geothermal and hydropower. Now, while I'm very supportive of these technologies, I think we can all agree that there's one key weakness that they have in common, one that industry will never address. In order for these technologies to truly provide reliable and affordable grid-scale electricity across these United States, they will require access to next-generation energy storage materials and technologies. To meet this need, strong and strategic support for basic research in materials science and computing through the Office of Science is absolutely critical. And that's just one example of the importance of this agency's work. In the past few decades, research conducted through the Office of Science has led to monumental discoveries in materials science, in computing, in fundamental physics, and biological sciences, and has enabled the development of innovative energy technology. Each DOE lab has made invaluable contributions to U.S. scientific progress, and they have repeatedly demonstrated that basic science research is the most effective way to encourage that innovation. Additionally, the unique open access user facilities at these Office of Science labs provides our nation researchers with the most cutting-edge tools of modern science, like advanced light sources, particle accelerators, and the 2 fastest supercomputers in the entire world. Each year, thousands of researchers from academia, other federal agencies, and U.S. industry partners, from Fortune 500 companies to even small businesses, rely on those DOE facilities to perform new scientific research and develop those new technologies. Thanks to the Office of Science and its decades of excellent work, the United States is the world leader in basic science research and technological development. But even as we speak, other countries, for example, China, are making significant investments in science and threatening our global leadership. The department's continued investment in basic and early stage research is vital, absolutely vital to the maintenance of our technological edge. By investing wisely in this research, the department can achieve its goal of scientific discovery and technological breakthrough for our future generations. DOE must also invest in facility upgrades and basic infrastructure that attracts and retains the best scientists in the world right here at home. I look forward to hearing from Dr. Fall about his plans to address these issues. I also look forward to hearing from Dr. Fall about DOE's ongoing implementation of several key pieces of bipartisan Science Committee legislation that was signed into law in last Congress, in fact, including the DOE Research and Innovation Act and the National Quantum Initiative Act. When basic research is the priority of federal support, everyone has the opportunity to access these fundamental knowledge that can lead to the development of those future energy technologies. I'd like to take a moment to thank my friends across the aisle for holding this hearing. I'm pleased to see, especially with our new chairman, I'm pleased to see that we're starting off the new year on the right foot by focusing on this key aspect of our jurisdiction. I'm going to thank Dr. Fall for being here today and a point of personal privilege, if I may, Madam Chair. It turns out that there's a bit of sadness here today because we are losing one Miss Emily Domenech, who is sitting behind me. She has been with our part of the committee for a long time. She keeps us on the straight and narrow, and that's a full-time job. So let's give her a hand. Can we recognize her help? And with that, Madam Chair, she's read, and I yield back.
Thank you, Mr. Weber. And I would now like to recognize Mr. Lucas for an opening statement.
Thank you, Madam Chair. And today we welcome Dr. Chris Fall, the Director of the Department of Energy's Office of Science, to discuss the program's priorities for fiscal year 2020 and beyond. Before he joined the Office of Science in 2019, Dr. Fall served as the Acting Director of the Advanced Research Project Agency's Energy, ARPA-E, near and dear to many of our hearts. These are two DOE programs where I'm pleased to say the Science Committee has found a lot of bipartisan agreement over the years. I look forward to carrying on that tradition this Congress, and I would like to thank Dr. Fall for his work. DOE is a world leader in technology development and scientific innovation. Through the Office of Science, the department funds robust research programs across the scientific disciplines, from material science and mathematical modeling to fusion energy science and the study of neutrinos. Discoveries made through the Office of Science are the force behind the development of next-generation energy technologies. They are the cornerstone of our clean energy future. If we are serious about the climate issues we discussed this morning, then we should equally be serious about our support for this agency and bold investments in basic research. The Science Committee has jurisdiction over all of the Office of Science Research and Development activities and its 10 DOE national laboratories, which totals $7 billion in annual spending at DOE. This afternoon, our discussion with Dr. Fall will focus on the programs within this critical jurisdiction. This committee has consistently supported robust funding for the Office of Science. In particular, its basic energy sciences, high-energy physics, advanced scientific computing research, and fusion energy sciences programs have long received bipartisan support from this committee. For example, committee members on both sides of the aisle have steadily supported full funding for the U.S. contributions to ITER, a high-priority fusion energy experiment funded through the Office of Science. I was pleased to see that fiscal year 2020 appropriations package included enough funding to maintain our participation in this world-leading international research collaboration. Fusion is the next generation scientific frontier, and with the potential to produce near limitless zero-emission power for centuries. Another one of our great areas of bipartisan agreement is the Advanced Scientific Computing Research Program, one of the Science Office's top priority programs. OSCAR supports the department's goal of completing the world's first X-scale computing system. X-scale systems will perform 1 billion calculations per second, and developing one is critical to enabling scientific discovery, strengthening national security, and promoting U.S. industrial competitiveness, thanks to DOE's targeted investments. The United States now hosts the top 2 fastest supercomputers in the world, Summit at Oak Ridge National Laboratory and Sierra at Lawrence Livermore National Laboratory. And the department is on track to reach X-scale by 2021. As other countries like China race to develop X-scale systems of their own, DoD's continued strong support of advanced computing is essential to the maintenance of U.S. leadership in this field. In order to support innovation in the next generation science, DOE must also invest in research infrastructure and cross-cutting research initiatives with other federal agencies. This includes Office of Science initiatives in critical research areas like quantum information science and artificial intelligence, as well as key investments in our nation's light resources and neutron resources. I want to thank Chairwoman Fletcher for holding this hearing and Dr. Fall for his testimony today. I look forward to a productive and valuable discussion. Our twin goals of addressing today's climate challenges with affordable, reliable, clean energy solutions and ensuring that the United States maintains a world leader in science and energy technology for years to come, while we continue our shared commitment to prioritize basic research supported by this critical agency. And with that, Madam Chair, I yield back.
Thank you very much, Mr. Lucas, for that opening statement. If there are other members who would like to submit additional opening statements, your statements will be added to the record at this point. At this time, I would like to introduce our witness. Of course, we got a nice preview, as Ranking Member Lucas mentioned. Dr. Fall is the Director of the Department of Energy's Office of Science, the lead federal agency supporting scientific research for energy applications and the nation's largest supporter of research in the physical sciences. Prior to his current role, he served as Senior Advisor to DOE's Undersecretary for Energy and as Acting Director of DOE's Advanced Research Project Agency for Energy, better known as ARPA-E. Before coming to DOE, he worked in various roles at the Office of Naval Research and at the White House Office of Science and Technology Policy. Dr. Fall began his career in academia, serving as a faculty member at the University of Illinois Chicago in the bioengineering and anatomy and cell biology departments. Dr. Fall, you will have 5 minutes for your spoken testimony. Your written testimony will be included in the record of the hearing. When you've completed your spoken testimony, we'll move on to questions. Each member will have 5 minutes to ask questions, and we look forward to hearing from you and then having an exchange. So please, your testimony can begin.
Well, Chairwoman Fletcher, Ranking Member Weber, and members of the committee, thank you for the privilege of being here today on behalf of Secretary Brouillette to discuss the remarkable work being done by the Office of Science at the U.S. Department of Energy. I've been director of the office since my swearing in at the end of May, and together with the researchers we supported our laboratories at universities and in the private sector, we're working both to discover the secrets of the physical world and to bring scientific discovery to bear on critical needs for energy security, economic competitiveness, and national security. I'm lucky to come to the Department of Energy at a special time of opportunity for American science. The House and the Senate clearly are aware of the intense landscape of international competition in research and development and the critical importance of maintaining U.S. leadership in science. With your support, the Office of Science funds tens of thousands of scientists, students, and technical and administrative staff. We continue to build some of the most amazing scientific instruments and open access user facilities in the world and to upgrade those that we already have. The Office of Science is currently beginning work on the deep underground neutrino experiment, a mile underground in South Dakota, and astronauts in December just extended the life of the alpha magnetic spectrometer orbiting 200 miles above ground attached to the International Space Station. We're upgrading both the Advanced Photon Source at Argonne National Laboratory and the Advanced Light Source at Berkeley. And we're building not one, but 3 game-changing exascale supercomputers in conjunction with the National Nuclear Security Administration. Just last week, we announced the launch of a new effort to build a game-changing electron-ion collider for nuclear physics. And while robustly supporting the traditional physical science mission of the Office of Science, we're in the process of launching and expanding a number of exciting new initiatives, including building the Quantum Information Science Centers as part of the National Quantum Initiative authorized by Congress, incorporating artificial intelligence and machine learning into many of the things that we do across the department, advancing biotechnology to grow the bioeconomy and to enhance biosecurity, and other research to promote the growth of industries of the future now being supported by the administration. We collaborate with the best scientists from around the world in our laboratories and in theirs, and at the same time, we're paying close attention to emerging threats like misappropriation of intellectual property and dual-use technology, and we're taking the necessary steps to help mitigate those threats. As we strive to push back the frontiers of science, we're mindful of the need to be the best possible stewards of the department's labs and user facilities. Most of the 10 Office of Science laboratories date to the Cold War or earlier. In our planning and in our budget requests, we are asking to renew and refurbish the physical infrastructure of these laboratories in order to sustain them for the future. It simply would be irresponsible to build something like a new accelerator or light source on a foundation of crumbling and unreliable electricity, water, and other critical infrastructure. So as we build new capabilities, we must continue to maintain and modernize our laboratory's basic infrastructure. I hope that you and your staffers will appreciate this balance that we are trying to achieve as you evaluate our budget requests. I'd like to mention in closing that the 2019 Nobel Prize in Chemistry was awarded to John Goodenough, Stanley Winningham, and Akira Yoshino for the development of lithium-ion batteries, a technology I think we can all agree has essentially changed our way of life. Both Goodenough and Whittingham are longtime DOE-supported researchers. For the Department of Energy's science enterprise, identifying and supporting incredible talent like these researchers is just one part of the commitment we have to push back the boundaries of what's possible. And as amazing as winning even a single Nobel Prize is, the department has supported over 100 Nobel Prizes. Because of the investment the American people make in robust support for basic research, because of the scope and scale of our laboratory system and the universities we partner with, and the remarkable scientists and staff we attract, the amazing happens each and every day. So thank you, Madam Chairman, for the opportunity to share the DOE leadership team's pride in the people and programs of our Office of Science and our laboratories. We are in awe every day of their dedication and their accomplishments, and I'm deeply honored to be their director. And with that, I'd like to try to answer any questions that you might have.
Thank you so much, Dr. Fall. We will begin our first round of questions. I will start recognizing myself for 5 minutes. And I thank you for the update, and congratulations to the entire team. I think we are all impressed by the incredible work that's being done. And I want to touch on two things you just talked about in your testimony. First, you mentioned competitiveness in the current environment, and we know that the Office of Science's National Labs has several world-class user facilities, including 5 light sources, 2 neutron sources, an array of particle accelerators, the fastest supercomputer in the world, Summit, which is located at Oak Ridge National Lab. In terms of the technological capabilities, power, capacity, and access, how do these facilities compare with competitors around the world, and how do our investments in these facilities contribute to the U.S.'s global leadership in scientific research?
Well, thanks for the question. I'd say they compare very favorably. Most obviously, supercomputing is the most famous, where we're sort of strikingly ahead at the moment. But it's a horse race, and so it's not a place where you can let up, your guard. We're developing new technologies. Particularly important are accelerator technologies, and these are also fundamentally dual use. So while we're pushing forward the frontiers of science and the capabilities of these machines, we're also developing technologies that are relevant to national security, as are other countries around the world. So we mentioned China earlier. They are very keen to compete with us, not just to have capabilities, but to attract scientists from around the world, which is what these world-class facilities do. So I say we're in a reasonably good place, but it is a horse race. Europe, the United States, China, Japan, it's not so differentiated when it comes to those key technologies.
Thank you. That's helpful. I think the other topic I definitely want to touch on is sort of in the context of this horse race and this competitive international environment. There also is an emphasis on international collaboration. And in your testimony, you mentioned the global nature of the research conducted at the Office of Science and threats to misappropriation of technology that raises with the international collaboration. Kind of relating to that topic, I think one of the things that's going on simultaneously is that the administration's been taking steps to restrict U.S. researchers from participating in some foreign talent recruitment programs as well. So I think what would be helpful to us is to understand what actions the Office of Science has taken in response to that directive, and also how you can balance the need, or how you are balancing the need for protecting against potential misappropriation and protecting while at the same time participating in the collaborative international efforts that benefit the American research enterprise. Can you just talk a little bit about that to us?
Sure. Well, let me start by saying that it's for the Department of Energy, it's not just the Office of Science. This has been the effort to deal with misappropriation of technology and foreign talent programs and other sorts of behavior we'd characterize as not in the best values, not in the best scientific and technological values around the world. We're following the same guidance from originally the Deputy Secretary, now Secretary Brouillette. Yes, we've made it clear that if you are a member of a foreign talent recruitment program, particularly related to countries at risk, you will not be employed by the Department of Energy. It's sort of that simple and that complicated. Now, we're also, at our laboratories, we've announced publicly that we've developed a technology risk matrix of key technologies and their relevance to economic and national security. And so we use that to evaluate how likely we are to collaborate with a number of foreign partners, particularly those for countries at risk. That's now a part of our laboratory structure as well. So that's whether or not we will collaborate in certain technology areas. And that's where we are right now. And what we're doing at this point is pausing a little bit, see what the effect is, because at the end of the day, I think we all understand that China is a science and technology juggernaut, and in the long term, we're not going to be able to just close the doors and shut the windows. We're going to have to find a way to modify behavior and work together in some areas with the Chinese. So we're looking for a response, and we're also pausing to allow the interagency to take a breath, figure out what we've all done, and together, what's more important than the Department of Energy putting out a new policy about this, that, or the other aspect of this, it's that we do all of this together with the other agencies like the National Science Foundation, Department of Defense, and others who fund research. So largely looking inward at our laboratories and our employees, not yet imposing policies on the extramural community that we fund at universities and so forth. Is that a...
Thank you. Yeah, that's very helpful. And I just have a little bit of time left. I did also notice in your testimony that you mentioned the hope of renewing and refurbishing some of the facilities, so that that comment was not lost. And part of my sort of last question that maybe you can just touch on throughout the hearing is the ways that we in Congress can help advance these policy and other initiatives from this committee. The things that we can do to be helpful to you would be very useful to us. So I've now gone over my 5 minutes, and I will recognize Mr. Weber for his 5 minutes of questions.
Thank you, ma'am. Dr. Fall, last week I was pleased to see that DOE announced the selection of Brookhaven National Laboratory as the site for the construction of the Electron Eon Collider. Eon, it's been eon since I've seen that word. An essential new nuclear physics research facility. That was funny, wasn't it? Yeah. As I mentioned in my opening statement, I feel strongly that these types of DOE National Laboratory user facilities provide American industry and researchers with the tools they need to maintain our leadership in science and develop new materials and technologies. But some of these facilities, like the Advanced Photon Source at Argonne National Lab and the Advanced Light Source at Lawrence Berkeley National Lab, are in need of those critical infrastructure upgrades we talked about. We want them to remain the best in the world. These are upgrades we pushed for with bipartisan infrastructure legislation that passed the House last Congress. In your prepared testimony, you mentioned that the Office of Science is currently working to upgrade both of these facilities. Can you give us a status update on both of those projects and then what new opportunities they might afford American researchers, please, sir?
Yes, I want to be careful. I'll circle back with particular details of dates and so forth, but we've certainly, for both of those, entered into the what we call in DOE jargon CD3A, which is advanced procurement for the kinds of long lead time things that we need to buy for these facilities. The magnets, for example, take a long time to build and source, and other materials like that. So the projects have gone through our stage gates and are on track and on budget, and we feel they're both of those are in good shape. And I do just want to differentiate, as you did, the projects, which are in great shape, from the underlying labs, which we still have some work to do on, and in terms of the infrastructure, like electricity in the case of these synchrotrons, light sources, that needs to be reliable. As you may have heard, Berkeley National Laboratory because of the fires in California, had to shut down twice at a significant cost to the taxpayer, because you don't just turn off the lights at these laboratories, and it hadn't, as far as the current leadership is aware, it had never shut down before. So twice in the space of just a couple of months. So the reliability, the multiple power sources, that sort of thing is kind of important.
And new opportunities it might afford American researchers?
Oh, absolutely. Every time so there's the science, and then there is the technology and the engineering that goes into building these amazing machines, and that is absolutely, diffuses out from the laboratory complex and has wider applicability. I'll just say something you may know already, that magnetic resonance imaging came out of the magnets for these facilities, right? I mean, the original magnet technology led to the development of magnetic resonance imaging that has changed our lives. And so all sorts of opportunities.
All right, we never know when that next great discovery is just right around the corner, so this is pretty exciting stuff. Dr. Fall, last week, the DOE announced the launch of the Energy Storage Grand Challenge, a comprehensive program that builds on the administration's Advanced Energy Storage Initiative to accelerate the development, commercialization, and the utilization of next-generation energy storage, the technologies that will sustain American global leadership in that particular area. As director of this Office of Science, what will you do to support and help make sure we maintain these initiatives?
Thank you for the question. It is a huge opportunity. As we know, there's a phenomenally good penetration of renewables in our country, wind, solar, others. The Achilles heel is grid-scale storage, and so that's why not just the Office of Science, but the Secretary has directed the whole of the Department of Energy. This Grand Challenge is a whole-of-department initiative, including NNSA partially. They have less of a role, but the applied offices and, of course, the Office of Science, where we do the fundamental work on batteries, characterizing batteries for one, materials, basic material science that feeds into the applied side for batteries and other modalities as well. So we're participating fully. Again, it's a whole of department effort at a very high level. This has the personal attention of the Secretary.
Real quick, in the time I have left, in your opinion, pardon me, what basic research programs in the Office of Science are the most essential to the development of that next generation energy storage technology?
Well, typically, energy technologies in general are a materials science problem. Critical materials and material science. That's what leads to a lot of advances in all sorts of advanced energy technologies.
Okay. Thank you, sir. And Madam Chair, I yield back.
Thank you, Mr. Weber. I'll now recognize Mr. Lipinski for 5 minutes.
Thank you. I'd like to thank the chairwoman for holding this hearing today, and thank you, Dr. Fall, for being here today. As director of DOE's Office of Science, you're responsible for overseeing the department's Advanced Scientific Computing Research Program. I think it's more important now than ever that the nation's leadership in high-performance computing is maintained because of national security, economic prosperity, and innovation that are critical to our country. And I'm proud that the first exascale computer in the nation, Aurora, will be built at Argonne National Lab, which is in my district. But I'm concerned that we're in a tight global race towards the completion of the first exascale computer in the world. I mean, it could be the first one in the world if we got there before China does. So I'd like to ask if you can give an update on the Aurora project and discuss the potential for exascale computing and the ramifications if we fall behind in this race. And I just want to say, I know Ranking Member Lucas has been there also and had mentioned exascale computing in his opening.
Well, thanks for the question, sir. I think we're in pretty good shape with the program. I will tell you, we're spending every penny that you apply to this program to move as quickly as we can. I do want to, and I think we will get there first with the machines, but there's so much more to high-performance computing than just the machines, and I just want to brag a little bit that we're covering all of those bases in a way that we believe that our competitors are not, and that includes the high-speed internets, interconnects between the generation of data and the computation on the data, our ESNet. That includes completely, at the same time we're building these exascale machines, reworking and modernizing the software stack that goes into those machines. And that's not a casual, that's a top-down, sort of once-in-a-generation reworking of this to move it from what amounts to cottage industry scientific computing to using the best software development tools and cross-disciplinary libraries for computation and that sort of thing. So there's a lot more to it than just the machines. We still think we're going to get there first on the machines. And again, we're spending every dollar that you appropriate.
So
on
so
those
are you saying you
machines.
need more
I
money?
can't. I wouldn't say that. I'd say we're just right where we want to be. But we're
Go
spending
ahead
every
and say you
dollar
need
that
more
you
money.
give us.
I'd be happy to hear you say it. So Aurora and other DOE supercomputers are just part of the department's work in artificial intelligence. And I know that the administration has taken steps to improve coordination on AI, but I believe that these coordination efforts could be improved. Earlier this year, I introduced the Growing Artificial Intelligence Through Research Act, which in part ensures that there is a central coordinating entity. So Dr. Fall, can you describe how the Office of Science, particularly the Advanced Scientific Computing Program, coordinates with the department's Office of Artificial Intelligence and Technology?
Sure, and maybe I could offer just a little more beyond that. We're so the AITO, as it's called, Artificial Intelligence Technology Office, is simply a coordination entity. So it doesn't run programs. It's not appropriated to run programs. The programmatic decisions on what to spend money on hardware, on software, and so forth happen in the Office of Science. They happen in the laboratories and programs under the Undersecretary for Energy and also in the National Nuclear Security Administration. But there's a lot of things that we don't need to do 3 different, 4 different, X different times. Develop the technology once, try a new hardware example once, and the AITO's job is to make sure that we are being as efficient as we can, and also, you know, getting out of our parochial focus on science and looking out to the remarkable blossoming of AI across the commercial sector, and make sure we're buying what we can buy instead of having to grow it ourselves or build it ourselves. So this office does play a really important role, and we're completely synced up with it.
And how would your AI efforts benefit from additional coordination with other federal agencies?
Well, we're there also, so I guess that's what I could have gone into there. So we are. This is a place where the White House is doing an exemplary job of coordinating across the federal government. There are at least 2 that I can think of, AI-focused bodies, one at a higher level and then a more working level. They meet regularly. I participate in those. We are connected because of them with the JAKE program in the Department of Defense and with other major, many agencies are now working on this. So I'd say the coordination is actually this is a good news story across the government. Coordination and a sense of purpose about the need to actually win at this game, and it is very important.
And if I can't return for another round, I just wanted to, give you a question about the National Quantum Initiative, and for the record. So I yield back.
Thank you.
Thank you, Mr. Lipinski. I'll now recognize Mr. Lucas for 5 minutes.
Thank you, Madam Chair. Dr. Foll, as you know, bipartisan Science Committee legislation, H.R. 4091, the ARPA-E Reauthorization Act of 2019, authorizes key reforms of the Department of Energy's ARPA-E program regarding research scope, program evaluation requirements, and efforts to avoid duplication. And being the next questioner after Mr. Lipinski, it's only appropriate that I ask you, as current director of the Office of Science and the former acting director of ARPA-E, can you please describe, using specific examples if you can, the level of intentional complementary research performed between the Office of Science programs and ARPA-E funded programs?
Yes, I could probably offer you after the fact of more of a laundry list of the opportunities, but let me just give you one earlier today.
And this leads us over into discussion about how you facilitate and make that happen, if you will.
So I can do that as well. We talked about fusion energy a little while ago. There's an example where just now we are working with ARPA-E to put together a joint funding announcement. There's one concrete example. The benefit to the Office of Science of working with ARPA-E is this sort of special forces nature of ARPA-E, that they can move quickly, attack a problem with a lot of focus and with energy derived from bringing people in from the outside to run those programs. And so we're always happy, if not to co-fund, then to co-scope. So when we're working up a funding opportunity in the Office of Science, we will, just as a routine matter, be involving program officers and even contracting officers, because of the way they know how to do business in a different way, into our process. This is what we did with the quantum initiative that we just launched last week. This was a cross-agency effort that included ARPA-E to, what are we missing here in terms of the ability to move quickly? Before Secretary Brouillette became secretary, as deputy secretary, he started something called the Arctic Research Technology Investment Committee at the undersecretary level, so NNSA, Energy, Science, and the deputy secretary, and ARPA-E for just this high-level coordination function, and that's going very well. The working group under that does topical deep dives like advanced energy storage, like artificial intelligence, and so forth, and reports up to the undersecretary level to assure that we are doing all the cross-fertilization that we can find opportunity for. And so that's relatively new. You may or may not have heard of that already.
Dr. Fall, as I mentioned in my opening statement, I'm pleased to see that the fiscal 2020 appropriations numbers have adequately provided for U.S.'s contributions to the EATR program, the world-leading international research collaboration into fusion energy that's received strong and continued bipartisan support from this committee. As Director of the Office of Science, what will you do in FY 2020 and beyond to help ensure that U.S. EATR programs receive the resources that it needs?
Well, we will follow the law. You've appropriated the money, and it will go.
Thank you first. That's a very important point.
Yeah.
Yes.
Of course, we'll follow the law. And the other, we're also working very hard, frankly, to stimulate our domestic fusion, including fusion energy startup community, that at the end of the day will feed into EATR and projects that go beyond EATR. So we recognize the intent of Congress, and we will follow the law. I will, if I can offer just a little awareness, I don't know if it was intentional, but I think it bears understanding that we did receive an increase of, I think it was $110 million in order to fund EATR, but received an overall increase for fusion energy for only about $107 million. And so the obvious consequence is we're making some choices there. And I understand budget negotiations are complicated, but we'd like to see, if I may, it's always great to have super support. We'd like to also support the domestic, be able to say that we're doing something in a relatively balanced way in terms of increasing support. If money goes to EATR, we'd also love for money to go to the domestic side as well.
Absolutely, Doctor. And as you well know, as authorizers, part of our process is to help in a polite way educate the appropriators about the common goals we all have together. With that, thank you, Dr. Fall. Yield back the balance of my time, Madam Chair.
Thank you very much, Mr. Lucas. And I would just like to note, Dr. Fall, that for the upcoming year, one approach you could take that would be particularly helpful would be if you submit a budget request for both of those items. And that would be helpful to us. And now I would like to recognize Mr. McNerney for 5 minutes.
Well, thank the chair, and I thank you, Dr. Fall. I think you have one of the most interesting and fun jobs in government. A little bit of jealousy here. But in your written testimony, you noted that your agency is, quote, in the process of launching and expanding a number of new initiatives, including incorporating artificial intelligence and machine learning into many of the new things we do across the department, sort of following up on earlier questions. I know that the DOE has recently established an AI and technology office, which was already discussed. Can you speak to some of the DOE's plans for leveraging its existing computing infrastructure to develop AI and keep our leadership in that area?
Well, I would say, yes, sir, existing and planned. All of these new exascale machines have artificial intelligence in mind. So we know we're designing the processing ability from the ground up to be able to handle traditional and artificial intelligence problems. And we're also, as we contemplate the construction and installation of these new supercomputers, thinking of a sort of plug-in testbed model. So I don't think there is technology available yet to scale to some of the new computing architectures that really fulfill the promise of AI, but small machines can be plugged into the large machines to test that capability, for example. So we're thinking this is being done in an extremely thoughtful way. I can say, again, both the hardware question for AI, the software question, and the use cases. So there's just a whole variety of use cases across the Department of Energy, and one that I'm particularly excited about because I'm responsible for these 10 laboratories is, it's no secret that Amazon and Google and companies like that use AI to improve their bottom line, right? They save money, they make more money by extracting data and understanding it. We think that we can use AI for operations in the Department of Energy as well. So think about acquisition, human resources, the use of, spending we do on energy, lights, and so forth, that we can turn those tools on the operation of our laboratories and even the department as part of this cross-agency AI push and get efficiency using AI in addition to the science and technology mission. So that's pretty exciting, I think.
Well, if you do that, then I hope you sort of develop products that can be used in the private sector as well. For the world to meet meaningful emission reductions in the next few decades, we'll need to invest in negative emission technology. I was pleased to see that in fiscal year 20, Energy and Water Appropriations Report directed funding to be used for cross-cutting initiatives between the Office of Science, Biological and Environmental Research and Basic Energy Sciences Program. Can you elaborate on specific plans and research in this area in the Office of Science?
I can tell you that we just discussed it this morning. We have specific plans to do it. We don't know exactly what those plans are yet. We've just come out of the budget cycle. But the question that we have, and we haven't made a decision, is whether to increase funding of existing hubs and mechanisms that we already have in place that do some of this work, or to go down different avenues, or both. We just have to make some choices, but we're on it, and I assure you that the money will be spent as directed.
Okay. Are flow batteries, do flow batteries have promise?
That's a good question. That's something that ARPA-E invests more in. We do basic, we could help with the basic chemistry there, but there's both the basic chemistry and the engineering of those things, and I think that's not my area of expertise, and so I'd like to get back to you on that.
Okay.
But on the negative emissions, I do want to acknowledge your direction to work with the Office of Fossil Energy on negative emissions, and we're having those conversations already, so that the direction is being followed.
So following up on Mr. Lucas's questioning, I'm enthusiastic about fusion power, or the prospects of fusion power. What are the different types of fusion power that are moving forward in your department?
Well, the two big ones are obviously inertial and magnetic confinement, and that's been the case for some time. One interesting opportunity that our ARPA-E organization has explored is that middle ground. And this is that middle ground is being sort of attacked by this amazing growth of a community of startup companies in this country. Thinking that these intermediate technologies, you don't need to build something as big as ITER or as big as NIF in order to get to a successful place in fusion energy, and we're very interested in continuing to support this community, both through traditional science and technology funding, but also through new mechanisms, using our labs as resources that these companies can access, potentially even moving towards what NASA calls their COTS model, for using Space Act sorts of authorities to put together public-private partnerships to grow industries. There's a lot of opportunity here, sir, and we're extremely excited about this. Both the participation in basic research and in demonstration projects like ITER, but also in this intermediate startup
there used to be
space.
the joke that it's 50 years and
Yeah, I'd
50
say,
years, but I don't think that's the case anymore, is it? I mean, we have real prospects now, right?
well, I don't want to do math in public, but it's still a ways off, but we're certainly moving much quickly towards that goal.
Thank you. I yield.
Thank you, Mr. McNerney. I'll now recognize Dr. Baird for 5 minutes.
Thank you, Madam Chair. And Dr. Fall, in your prepared testimony, you state that one of the Office of Science's goals is to enhance the U.S. Biosecurity. So I come from an agricultural background, and I represent a district that is deeply rooted in agriculture. So could you share what might be being done in the biosecurity in that agricultural?
Yes, sir.
industry?
Well, less in agriculture because that's the mission of the Department of Ag. You know, we're sort of constrained a little bit by the rules and the laws about what we can work on, but the enabling technology is something that we've been doing stretching back to our participation in the Human Genome Project. So we know how to sequence genes. We know how to understand what genes do in cells. We're very interested to leverage one of our superpowers in the Department of Energy, and that's convergence. That's putting together biology with physics and mathematics and computing to understand biology in a fundamentally new way and explore the opportunities of engineering biology for health, for products, for agriculture, but also, you know, when you can change biology, there's a threat involved. And so understanding what the threat space is and being prepared to defend against that is something that we can do at the Department of Energy in a sort of unique way.
Thank you. Also, you gave us some indication about the implementation of DOE's policies to prevent foreign infiltration, specifically in DOE's basic research base and at the national labs. Could you elaborate on that, or at least give us some idea how we're preventing foreign infiltration into our basic research?
Well, we're doing a number. I did mention that we have a policy about the foreign talent recruitment program. So this is a way of recruiting, basically appropriating technology from other countries. That's a no for us. At the same time, we're massively increasing our ability to understand who is at our laboratories. Who's at our laboratories, where are they from, what are they asking to do there, and have a filter for that. That's really important, while recognizing that science is a fundamentally international activity, and we lose by saying no to everybody. So it's a tough problem. So the foreign talent program's relatively easy. The understanding who's in and who's out of our laboratories is also relatively straightforward. Then we have to make the decision about who to let in and who not to let in. Fundamental to all of this is enforcing policies that we've actually had in place, as have other agencies for quite a long time, and that's disclosure. If you're gonna come and either work for us or work with us, we ask you to tell us who's funding you, where are you from, what are your affiliations, and the first step is to require disclosure. Second step is to ask, well, is the disclosure truthful? That's a whole separate line of business. But just that act of saying, in order to work with us, you need to tell us who you are and what you're all about, is important. And surprisingly, over the decades, agencies, not just ours, but I think all of us, have gotten a little bit lax about enforcing the requirements that always came with grant applications and applications to come visit and so forth. So that's a really important part, the disclosure part.
I can appreciate that is a real challenge, because you don't want to be so restrictive that we can't advance, scientific advancement, but at the same time, you'd like to have others share in the cost of getting that done, not just American taxpayers. So I thank you for your comments, and I appreciate you being here today, and I yield back.
Thank you.
Thank you, Dr. Baird. I'd now like to recognize Mr. Foster for 5 minutes.
Well, thank you, Chairwoman Fletcher, Ranking Member Weber, and Dr. Fall for joining us today. First off, I'd like to congratulate you on the siting decision on the IAC at Brookhaven. These siting decisions are really tough, and Congress often does not make them easier. But as someone who's sort of a connoisseur of technical design reports, and also probably even more importantly, the physics capability documents that really are the important ones to look at on these when you have competing proposals. I can tell you, at least from my opinion, you made the right decision technically and for the physics from these. And your timing was also excellent, because the National Labs Caucus was already planning a visit to Brookhaven at the end of this month, which you're very welcome to come to if you can make it there, or send somebody to join multiple members of Congress. Now, as you know, Argonne National Lab in my district is working very hard on supercomputing as well as artificial intelligence. I think last November it sort of snuck under a lot of people's radar screens, but Argonne tested in a commercial partnership with Cerebras, a giant wafer scale, the fastest AI engine in the world. And this is the sort of commercial partnership that is, it's great. It's the wave of the future in AI, with so much commercial money going into it. But the main program at Argonne is Aurora, which we hope will be the first X-scale computer on Earth. Certainly will be in our country. But I'm a little less sanguine about the probability that the Chinese won't beat us in this. And at least some of that's due to the fact that Congress delivered a little less money than Brookhaven had requested in this year. There's a shortfall there. But one of the ways that you have available to partly make up this shortfall is with the $71 million for AI and machine learning that for a number of Office of Science programs. I was wondering, have you come up with a plan for how to allocate that money, and is it likely that that may be useful for helping some of the shortfall in the Aurora effort?
Well, I'd be reticent to commit to moving money from one to the other, because then we get the other side
there's certainly
complaining.
overlap.
But there is opportunity there. We haven't decided how to spend all the dollars in terms of exactly where they're going, but we kind of know what we're going to spend it on. There's just a ton of, as you know from your background, just a ton of opportunity from enhancing the ability of these machines to do calculations in a new way to, at the front end, sort of pre-computing, pre-calculating, pre-sorting the massive data that comes out of the science machines, right? All along the way, never mind, running something like an accelerator using AI as an assistant, if you will. So across everything we're doing in the office, I talked about AI for operations at the laboratories. That's, I think, novel and innovative for a federal agency. But what's clear is the opportunity for us across the basic science. That's why we're spending so much money on it. It's not by accident. So I want to be cautious about committing to moving money around. You can be assured that we're moving as quickly.
Because, it's obviously these are combined hardware-software
That's right.
efforts, and there is some degree of fungibility
That's right.
once the money hits the laboratory. And if you build the hardware and don't have the software in place, the algorithms, the scientific participation, you don't get nearly as much out of that hardware. So another thing that came up actually in response to the previous questions involving biology is one of the real areas of growth recently is in so-called cell-free technologies, where you take advantage of the enzymatic pathways that nature provides, but you don't have these annoying cells around that, proceed to, evolve and do other things to wreck your culture. I was just wondering if that's something where you think there may be a natural area of participation for the Office of Science.
Well, absolutely, because what that allows is science at scale, which is what we do. It's the high throughput paradigm. When you can do cell-free systems in multi-well plates using robotics to do the mixtures and so forth, that's where you get a whole lot of information very quickly, and that's the kind of thing that the Department of Energy does, is big science, big machines, integrated data, and so forth. So I would say yes.
So I just encourage you to have a look at that, because it's a new field, and it sort of falls between the cracks in some ways. And then finally on quantum, there are three broad buckets. There is building quantum computers with technology at hand. There's quantum instrumentation and sensing, which is a often separate thing. And then there's developing fundamental sciences, new materials and devices in support of quantum. And to make it even more complicated, you have military off on the side, you have significant efforts commercial. So how do you make sure that the Office of Science is focusing on what you can uniquely do best there?
And I would also add, I think you mentioned, but I'm not sure, quantum communication exactly, which is also low-hanging fruit. So yes, we're the nation's experts in material science. Quantum is another place, like advanced energy, where it's all about materials at this point, and also systems engineering when you start to think about the cooling required and so forth. So we are being very cautious. I think that some of the direction that we're going to go in will shake out of the process by which we choose these quantum centers that we've just announced. We're expecting a whole lot of input, not just innovative science programs, but innovative collaboration models and so forth. And so I think there's a lot of opportunity there. And I don't want to get ahead of my skis in public here, but I think you're going to hear more very soon about quantum networking and communications on a larger scale. And so we're moving as quickly as you allow us to with the
Thanks much. Thank you for doing a great
resources
job.
you
My
provide.
time is up, and I'll have to yield back.
Thank you very much. I'll now recognize Mr. Cloud for 5 minutes.
Thank you, Madam Chair. And Dr. Fall, we appreciate you being here. You mentioned that China is a technological juggernaut, and it occurs to me that this isn't because of necessarily major breakthroughs that they've made, but rather our naivety toward them over the last few decades, and the fact that they're stealing technology from us and others. Can you talk to us, you mentioned some things that we're doing in the sense of being careful about who we're allowing to work at the labs and such, but could you speak to what else DOE is doing to better secure the Office of Science Research against, for example, cyber theft?
Well, we have a broad, yes, I can, and we do have let me start by saying much of what we do in terms of results is public science anyway. You know, we publish the work because we're a basic science organization. But many, but not all of our laboratories, because they're funded by multiple sources, also have national security missions, and we sit in a department that has perhaps the most sensitive national security mission in the country with the strategic deterrent and those weapons. We know how to do security, and we live in an environment. It's funny that I often complain about how most Americans don't understand the role that the Department of Energy plays in science. They don't know that we have labs. They don't know that we all do all this work, and that's because we spent the first 70 years of our existence not telling anybody what we do, right? So we understand security. I think actually part of the problem is actually advertising the amazing things that we do. The Secretary Perry, before he left, stood up CSER, Cybersecurity and Emergency Response Division in a whole new assistant secretariat in the Department of Energy, just focused on cybersecurity, and that's cybersecurity of the grid, cybersecurity of the lab, cybersecurity of operations. We're attacking the problem. We understand that it's a problem always, but we do come from a posture of understanding security problems. It's not a naivete, if you will.
Yeah, I guess the picture I always have in regards to China and funding, I mean, we spent, I think, $7 billion last year from Congress, and it's the picture of this bucket that we're pouring into, but there's a hole in the bottom going into a bucket that China's sitting there, you know? And so when we think about how to expand our capacity, it's not just more funding as it is sometimes, I think, closing that hole a little bit so more stays in our bucket. In regards to, we know China's sending foreign actors to universities, for example, as well. Some of our research dollars are going to universities and working with that. Of course, that's not every student there, but certainly there are foreign actors. Is there anything that we're doing in regards to make sure that research funding that's being funded by taxpayer dollars isn't going to fund the China government initiatives?
Yes, sir. We're not rolling out any policies at this point, but we are having, this is a little bit earlier I mentioned that we are participating with the interagency. We want to make sure that any steps that we do take regarding extramural research to universities and other organizations is done in coordination with all the agencies so that we do it the same way. Right. It's not going to work to have one set of, for all sorts of reasons, it's not going to work for the Department of Energy to have one sort of rules and NSF another set and so forth. We recognize the problem and we are actively discussing alternatives. It will probably take some authorizing changes to authorization and so forth, because there are rules about how you, open access here to funding and so forth.
Right. Okay. Shifting gears a little bit, could you compare, contrast where we are in China when it comes to AI, and then specifically what the DOE is doing to apply advancements in AI toward how we manage our electric grid?
Yeah, I would defer the Part B, which is the electric grid, to the Assistant Secretary for Electricity, just a little, but I can tell you that we're working closely together. The Office of Science provides the basic AI technology, the machines and so forth, and frankly, the connections out to industry and academia, they're leveraging it. I'm not current on exactly what they're doing, but I know it is a complete priority. The Office of Electricity and Cybersecurity and Emergency Response Assistant Secretary is for protecting the grid, which is largely an Internet of Things. I mean, it's absolutely a threat. Part A was, I'm sorry, China and...
Compare our capacity.
Yes,
to
AI.
China when it comes to
Yeah, this is another place where it's a foot race with no clear, I would say no clear, it's hard to say who's ahead in AI, frankly, and I think most experts would agree. There are, AI is a little bit still of a boutique industry. There are more researchers in China working on AI than there are in this country, and also one of the key enablers of AI is data. And we all know, you don't need to have a poor social score to understand that China is amassing a lot of data on people and things and processes and putting it together for use in a way that we don't in this country on principle. And so there is an advantage there for them in terms of AI, but of course the consequences are things like that we prefer not to entertain, like
Right.
personal social
Rightfully so.
scores,
Yeah,
right?
Right. Well, thank you. I yield back.
Thank you, Mr. Cloud. I'll now recognize Mr. Lamb for 5 minutes.
Thank you, Madam Chair. Dr. Fall, thank you for joining us today and for all your service to the country. In 2018, the Department of Energy Research and Innovation Act was signed into law, and I believe it required the reestablishment of a low-dose radiation research program. The idea being that a lot of the basic scientific data underpinning radiation limits and requirements had a lot to do with survivors of the atomic attacks. It might not have been as directly relevant to, for example, the plant workers at the nuclear plant in my district who experienced low levels over a long period of time. So with the goal being just accuracy as far as what we know about where those measurements and what those regulations need to be for the health of the workers, but also the competitiveness of the industry. So I think, again, in FY20, we directed the establishment of another low-dose radiation research plan, or same one, just funding for it. So just asking for an update on progress in that area. Does that sound familiar to you?
Yes, sir, of course. And I'm going to be really careful with the words because I think it was established, not reestablished, and that's germane because our position is that there are some new opportunities here, technologies that we didn't have originally, things like computational, things like cell-free and other mechanisms for exploiting. So we're actively, we understand we've been directed to do this. We understand that we're directed to spend a certain amount of money. I believe it's $5 million this year. We're going to do that. We're in active conversations with the National Cancer Institute at NIH, who has similar problems if you think about the causes of cancer and the impact of imaging like x-rays and so forth. So they want to understand this as well. So we're working with them as well as an interagency group under the Office of Science and Technology Policy who's getting together and saying, hey, here are our options here. It doesn't make sense to do 5 different things. Let's get together on a low-dose program. So we are following the guidance, we think, in a way that makes sense, and I'm happy to get you more detail on that. I do know that we haven't made any particular funding decisions on people or places yet, but happy to keep you up on the details.
Great, just making sure it's underway. Thank you.
Absolutely is, yes, sir.
And then I wanted to ask about fusion, and some of my colleagues did as well. And I had the chance last summer to visit the project up at MIT, which is really just an impressive and fascinating piece of work, and they're doing pretty well now with private sector funding. And one of the things that I came to understand in the history of that project was the importance of federal funding, you know, throughout so many years of their history, particularly on the research on the magnets. And now they're not really receiving federal funding for that project anymore. And so first question is just kind of in line with what you said earlier about the $110 million and the $107 million. Are you concerned that too much of our federal share of fusion research, or all of it, is going to ITER, basically, in the sense that we're kind of putting all of our eggs in one basket as opposed to cultivating some fusion research here at home at the same time?
Well, I wouldn't go that far because obviously it's a $670-something million program, fusion, plasma sciences, and so forth, and some part of that is going to fusion, 240-something, I believe. I'm more worried about the balance. I'm worried about sustaining both. If we're going to participate in ITER, we also should be paying attention to nurturing these folks. We have a lot of great ideas. And of course, there is an enduring question is if there's going to be a demonstration project in this country, should there be one here? Sorry, in the world, should there be one also here? I can offer that there's probably, we love all of our programs equally. I think I can offer that our Undersecretary for Science, there's no program that's more important to him than getting fusion on a right path, and so we're paying an awful lot of attention to this.
Perfect. And if I could just ask you right before my time runs out, there was this National Academies report at the end of 2018 that kind of talked about doing demonstration here at home, but particularly emphasizing the advances in high temperature magnets and kind of a smaller, faster, more efficient approach. Is that promising? Is that something you think the government should be investing in? And will we need to give new authority to make that possible?
High temperature superconducting magnets. Yes, and well, I don't want to say we should go forward. What we are going to do, what we've already done, is contacted the National Academies. It was the Burning Plasma report, and asked them to do a follow-on discussion. They recommended doing a demonstration plant, but with no guidance beyond that. We'd like them to explore that in detail, tell us the options, tell us what they think it would cost us to do that. We've already started the conversations with that to get more information. It's certainly something we should understand, and then we weigh, the costs and benefits of doing it here versus other places.
Excellent. Thank you very much. Madam Chair, I yield back.
Thank you, Mr. Lamb. I'll now recognize Mr. Caston for 5 minutes.
Thank you, Madam Chair. Thank you so much, Dr. Fall. I think I'm the only thing between you and the end of the evening.
I'm enjoying this.
Really appreciate you coming out. I have the good fortune to have a district that just to my west is Fermilab and just to my south is Argonne, and have had the pleasure of touring both and meeting with a lot of your scientists multiple times. And I appreciate having the opportunity to nerd out so close to home. So I appreciate that. I want to talk specifically about climate change and what we're doing for it, which is, in many cases, a deployment problem. We underdeploy lots of proven technologies. But there's a hugely significant role that the national labs play. And in particular, there's some really interesting work going on at Argonne around energy storage. And I've been involved in the Promoting Grid Storage Act to increase funding, and I don't know if it's sufficient, frankly. But at core, we have more than enough clean, zero-cost energy to run the country. But it isn't where the loads are, and it's not always running at the time that the loads are there. And either we need to figure out how to build a lot more transmission than we've figured out politically how to build, or how to deploy a whole lot of storage around the grid at a cost level that's an efficiency level that's much higher. So could you, I think we gave you a $420 million increase in your budget last year, which I look forward to hearing how you're going to use, but tell me, if you would, where you see the gaps in energy storage and, if you'd like, transmission from a science perspective, what we are doing and what we should be doing more of to try to bridge those gaps.
Well, thank you for the question. Someone was asking earlier about cybersecurity for the grid and the intersection of AI with the grid. I would say there's also what hasn't been mentioned here today is the opportunity that automating the grid provides for squeezing more out of it. So, using AI, using internet-enabled, using, computational technology to understand energy flow on the grid lets us do more with less generation, for example. But that said, this is why the advanced storage, we talked a little bit, earlier about the energy storage grand challenge. I think that we feel in the department that we're on a great track and moving rapidly, mainly due to market forces, frankly, on the deployment of renewables. We're also, but the Achilles heel for more renewables, you reach a point, you have to have storage. You've got to have the load, available, as you said, reliable, electricity is really important, and so this storage is the most important piece, and that's, I would say, of all of this, of storage and renewables and so forth, something we do in the Office of Science in terms of materials science, something that ARPA-E does a lot more of, something that EERE, Energy Efficiency Renewable Energy, does a lot more of in terms of closer in technologies. I don't know if I've happy to
Well, I'd like-
go back
yeah,
and forth here. I think I
Yeah,
got
no,
off
love
track
to
on your
continue the
question there a little
conversation. I mean, I don't, it's not meant to be, there's no right answer to the question. I just know that if we're going to get to 100% renewability, we got to solve that storage problem.
Storage problem, exactly.
Both
right,
in terms of
right,
the technology and the deployment.
right.
With the time I got left, I want to talk about the science of climate change. It strikes me that we have two significant gaps. There's one gap that we talk about ad infinitum, which is true, that climate models are uncertain and they get tighter and tighter, and there's better and better computational power. And I've never met a scientist who didn't want a bigger computer. And so that's fine. As against that, we have really limited tools to understand what the impact is of the policies. So, we had, hearings this morning that, one of our witnesses was talking about changes in agricultural policy, trying to get a good understanding of, okay, if we want to get to this goal of parts per million in the atmosphere, how much can this agricultural policy change on a permanent basis accomplish? These are scientific questions. So you can take either or both, but what do you think we could be doing better, both to have better predictive models of what is going to happen under various scenarios, and on the other side, better models to understand for a given policy change or behavioral change, what's the impact going forward? Because that's going to affect the amount of flow into the system.
Right. Well, I'll pass on the second because that's not my area of expertise, and I'll maybe talk about the computational side. We've made a big deal today about these exascale computers. I talked a little bit about the software stack that goes into that, and one of the things we are doing under the BER division is completely rebuilding these Earth systems models. At the end of the day, it turns out that size matters, and what do I mean by that? The scale at which you do these computations, actually, you have to go small. You have to use an exascale supercomputer in order to capture the nuances in these Earth system models, and so that's what we're buying with these exascale machines. Exactly what you said, better precision on the computation, and it's not just a wish list for science. You have to do that in order to be able to predict the weather. The better you do, the smaller spatial and temporal scale you compute on for these predictions, the longer your prediction is valid. That's for weather, that's for Earth systems, that's for all of these things. And so I think we're moving in a great direction. This is a huge effort in this division of ours to fundamentally, from the ground up, rebuild with the interagency. It's not just the Department of Energy, it's working with NOAA and these other agencies who have a dog in this fight to rebuild the Earth systems modeling.
Thank
I
you.
don't know if that's helpful.
Thank you. I yield back.
Thank you, Mr. Kasten. Dr. Fall, we are almost finished, but because you gave us some really interesting things to think about, I'm going to just open
Where
up
did I make
for
a mistake?
an additional round of just
When
a
you
question.
showed up.
Just a question. So for any remaining committee members, if you have an additional question, I'm going to open it up for that. I wanted to follow up on your question and answer with Mr. Lamb and just follow up a little bit on the ITER question. Because my understanding is since his appointment as Director General of the ITER International Fusion Project 5 years ago, Dr. Bigo and his team have made remarkable progress in improving the management of what may well be the most complex scientific project in the world. As you know, the U.S. played a leading role in pushing for major personnel and management changes that have gotten the project back on track. But the last 3 budget requests for ITER have been a fraction of the DOE-approved estimates for what it will take to minimize the project's total cost to U.S. taxpayers and to maintain the current schedule. So I guess it's my question is, do you agree that the DOE's most recent budget requests for ITER have been a fraction of what it will take to minimize the project's total cost to U.S. taxpayers and to maintain the current schedule? And if so, how will you address that going forward?
Okay.
Easy question.
Well, first of all, let me say that Bernard Bigot is an international hero. He absolutely has turned around the ITER organization absolutely brought a remarkable difference to the management of the project, and things are going in a much better direction. And it is true that the budget request that we made is less than what we've frankly committed to in the international agreement that we're a part of. I'm not willing to go beyond that in terms of motivation. It's not, that's between you all and the president at some point. What I will commit to, as always, is, you tell us what we're going to do, and we will do that. We will follow the rules, the law, and spend the money that you instruct us to do.
Thank you very much for that, and I do appreciate your answer and explaining to us where we are, and I know that this committee has been particularly interested in, and Chairwoman Johnson in particular has worked hard to ensure that the funding is appropriated and that goes through the process. So thank you for clarifying that for us. That was my one question, so now I'm going to turn it over to and recognize Mr. Weber for a question.
Thank you, ma'am. Dr. Fall, we talked about earlier in your testimony about infrastructure and the need to upgrade and the basic infrastructure of the national labs. And we talked about we couldn't attract the world's best talent if we didn't do that. One of the questions I didn't get to ask was, have you seen that state of our national labs, the basic infrastructure state needing repair? Has that been an impact? Have you noticed, seen, heard? Has that impact or had a high impact on the workforce retention out in community, out in industry? Are you aware of any of that? Has it been an impact on workforce retention?
In our laboratories, yes.
In the labs,
at the end of the
course.
day, in a tight labor market where there are a lot of choices, these things start to matter a lot.
Right.
The mission, one thing that brings folks to our laboratories is the mission, but at some point, if they get paid less and they also show up to a leaky building with old computers and all that kind of stuff, it starts to take a toll.
Right.
Yes, sir. It's important to provide modern, effective workplaces to technical people.
So that's obviously impacted the labs. And when do you know when people leave the labs? Do you have a sense or know of where they go? And the quicker they come in and out, has it impact the workforce? In other words, if we could retain them longer, get them trained up, and get them really solid, would that help industry? Do you have any sense of that
Would
at
it
all?
help industry?
Yeah.
Industry side. I guess I'm not following your question exactly, but let me just take one step back and say my personal opinion is we've got these three legs of the stool. We've got industry, we've got academia, and we've got our national labs. And I'm very comfortable with a robust flow between those sectors.
Sure.
The problem we actually have is we make it hard for people to leave and come back, and this is what people want to do. They want it. So if we could lower the barriers, I think we'd all be in a better place, industry and the labs. And
Well, that really is my question, because they could go to the labs, great training grounds, get
Yes.
a lot of good work in,
Right.
take that expertise, go out into the industry with
Yes.
it, and then do really good stuff for industry. But if we're not kind of a training ground, if we're not where they're applying that, I just didn't know if you were getting any sense from industry around, look, we're just not getting as many qualified people as we used to be, because they come in, they don't stay that long, they go somewhere else pretty quick.
in the labs.
And from the labs, yeah.
That's right.
And that's what.
I mean, this is again, tight labor market, lots of choices, a lot more money in other places. That impacts us particularly in things like AI, computer science, and so forth. Hard to find too many places with particle colliders or synchrotrons. If that's your thing in
It's
life.
not on
then
every
you're kinda-
corner.
That's right.
Okay. Although I've seen some streets in Texas where there is a lot of colliders on the corners. Thank you so much. I yield back.
Thank you, Mr. Weber, and thank you for the comic relief. It's always appreciated. And with that, I do want to bring the hearing to a close. But before we bring the hearing to a close, Dr. Fall, I really want to thank you for coming and testifying and answering our questions today. The record will remain open for 2 weeks for additional statements from members, additional questions the committee may want to ask. But I thank you very much for being here, and now the hearing is adjourned.
Thank you. My complete pleasure. It was fun.